Let's try that with another example. What about negative 2 and 8? Negative 2 and 8. There's no question about the values here. I've just got two numbers. Negative 2 is less than 8. Now let's try them in reverse order. 8 and negative 2. 8 is greater than negative 2. Notice that when we switch sides, negative 2 first, then 8, switching to 8 first, then negative 2, the inequality symbol changed from less than to greater than. The inequality symbol's direction reversed. This leads us to a rule that is starred. Be sure you write it down accurately in your notes. This rule says A is less than B, A is less than B, is equivalent to B is greater than A. A is less than B is equivalent to B is greater than A. A is less than B is equivalent to B is greater than A. Writing this without so many symbols, we get the statement, switching sides in an inequality reverses the inequality symbol. Switching sides in an inequality reverses the inequality symbol. Switching sides in an inequality reverses the inequality symbol. This is something you'll need to be aware of as you work with inequalities at all levels. Be sure you have this well inside your mind. Now, what else reverses the inequality symbol? Well, let's take our inequality that says negative 2 is less than 8. Negative 2 is surely less than 8 because a negative number must be less than a positive number. Now let's add something to both sides of this inequality. Negative 2 plus 5, 8 plus 5. I have left blank the space for the inequality symbol. To verify what needs to go there, let's finish up the left-hand side and the right-hand side. Negative 2 plus 5 is 3, and 8 plus 5 is 13. Now we can compare 3 and 13. 3 is less than 13, which means that the unsimplified version of the same thing is less than. So the inequality symbol that began as less than remained unchanged as we added a number to both sides. We added positive 5. What would happen if we subtract or add a negative number? Well, let's try the same inequality. Negative 2 is less than 8. And subtract or add a negative number to both sides. I've chosen negative 4. Negative 2, add negative 4. And on the right, 8, add negative 4. Excuse me. Adding the negative 2 and negative 4, we get negative 6. Adding 8 and negative 4, we get 4. Negative 6 is less than 4, which means the unsimplified version is less than. Notice that adding a negative number keeps the inequality symbol unchanged as well. These are illustrations of the addition property of inequalities. The addition property of inequalities. This states that adding the same number to both sides of an inequality keeps the inequality symbol unchanged. Addition property of inequalities. Adding the same number to both sides of an inequality keeps the inequality symbol unchanged. Adding the same number to both sides of an inequality keeps the inequality symbol unchanged. Remember that with equations we have two properties, an addition property and a multiplication property. So let's see what happens to an inequality when we multiply by a number on both sides of the inequality. So let's start with our same inequality. -2 is less than 8. Let's multiply both sides of this inequality by some positive number. So we'll take -2 is less than 8, multiply both sides by some positive number. I've chosen 3. -2 times 3 on the left, 8 times 3 on the right. Let's simplify to determine the inequality symbol. We get -6 and 24. Well, -6 is certainly less than 24, and so the inequality symbol remains unchanged. Next example, we'll take our favorite -2 is less than 8 and multiply by a negative number. I've chosen -6. -2 times -6, 8 times -6. We'll simplify to determine the inequality symbol. -2 times -6 is 12. 8 times -6 is -48. 12, a positive number, is greater than -48. That means that at the moment we multiplied by -6, the inequality symbol became greater than. So we notice that this time the inequality symbol reverses. The inequality symbol reverses at the moment we multiply by a negative number. Let's take -2 is less than 8 one more time and divide by a negative number. I've chosen -4. Remember that dividing is like multiplying by a reciprocal. Well, -2 divided by -4 is positive 1/2, and 8 divided by -4 is -2. Positive 1/2 is greater than -2. So that means that at the moment we divide by -4, the inequality symbol is reversed. It switches from less than to greater than. So we have two places where the inequality symbol reverses. The two places we've starred, which are the places where we multiply both sides by a negative number and where we divide both sides by a negative number. This leads us to the multiplication property of inequalities. The multiplication property of inequalities has two parts. This is a lengthy statement because of the two parts, so copy very carefully. The first part says, multiplying or dividing both sides of an inequality by the same positive number keeps the inequality symbol unchanged. Multiplying or dividing both sides of an inequality by the same positive number keeps the inequality symbol unchanged. A key word here is positive. Multiplying or dividing both sides of an inequality by the same positive number keeps the inequality symbol unchanged. Part 2, multiplying or dividing both sides of an inequality by the same negative number reverses the inequality symbol. Multiplying or dividing both sides of an inequality by the same negative number reverses the inequality symbol. The key word here is negative. Multiplying or dividing both sides of an inequality by the same negative number reverses the inequality symbol.